ESE Pedia. General Studies video lectures, notes and practice. Question sets for engineering service examination, and other conducted examinations. In this video we had discussed a subtopic of energy and environment, which is environmental pollution. And the second topic comes under environmental pollution is water pollution. Water pollution may be defined as the presence of undesirable substances, organic, inorganic, biological or radioactive in water, and such physical factors as heat, which make it unfit and harmful for use by the human beings, animals and marine life. Marine water pollution has assumed greater significance because in the present age of technology and large-scale industrialization, the coastal areas of oceans and seas are most vulnerable to pollution. These areas receive direct discharges from the rivers, which carry a large amount of dissolved and particulate matter. The oceans and seas are being used as endless dustbins for wastes. Sources of water pollution. Major sources of water pollution are as below. Domestic sewage. Human beings use water for drinking, cooking, bathing, washing clothes, gardening, recreation, etc. The discharged water has soluble and insoluble, organic and inorganic matter. It includes detergents, toxic heavy metals and even pathogens. In the municipal drains, the domestic sewage is mixed up with garbage from urban and rural settlements. This highly polluted water is discharged into rivers, lakes and ponds. Thus the domestic waste and garbage are the main source of water pollution. Industrial waste. The industrial wastes are most harmful of all water pollutants as they contain toxic metals lead, mercury, zinc, copper, chromium and cadmium, and toxic non-metals arsenic, acids, alkalis, cellulose fibers, coloring and bleaching materials, petrochemicals, etc. These pollutants are continuously discharged in the water bodies, either directly or from waste dumps. Agricultural wastewater pollution caused by agriculture is mainly an outcome of fertilizers and agricultural chemicals such as insecticides and herbicides that run into streams and lakes. They are rich in many nutrients and lead to phenomena like eutrophication. Offshore oil drilling. This pollution is mainly due to the loss of oil during offshore exploration, oil drilling and extraction of mineral oil, leakage of oil and natural gas from underwater pipelines, and oil spills from oil tankers. The waste oil also reaches the oceans and seas due to leakage during loading and unloading of oil tankers, runoff from the roads at seaports, and washing of oil tankers. Thermal pollution. Most of the large-scale industrial units, thermal power plants, nuclear power plants, oil refineries, etc., are located along the banks of rivers. These industries use large quantities of fresh water for cooling purposes. The hot water is generally discharged in the rivers. This increases the temperature of river water by about 10 degrees Celsius, and this leads to thermal pollution of water. This has a harmful effect on the aquatic organisms, such as fishes and algae. The increase in temperature of river water also decreases the level of dissolved oxygen, which results in the release of foul and toxic gases. The effects of water pollution. The pollution of fresh and marine water has harmful effects on the environment, human health and other organisms. The effects of different sources of water pollution can be discussed as under. The domestic waste and sewage has the following effects. It can cause infectious diseases, such as typhoid, cholera, dysentery, jaundice, etc. The presence of pathogens make it unfit for domestic use. The reduced oxygen level causes foul smell. The industrial wastes have the following effects. The water cannot be used for domestic purposes. It has caused extinction of a number of marine species. It includes toxic metals lead, mercury, zinc, copper, cadmium and chromium, and toxic non-metals arsenic, petrochemicals, acids, alkalis whose effects can be 1. The accumulation of lead in human body damages the nervous system, kidney, liver and brain. The children and pregnant women are most affected by lead poisoning. 2. Mercury and its compounds can cause abdominal problems, headache, chest pain and diarrhea. 3. Zinc can cause renal damage and vomiting. 4. Copper can cause hypertension, dizziness and drowsiness. 5. The accumulation of chromium can cause diseases like cancer and disorder of nervous system. 6. Arsenic can cause liver cirrhosis, lung cancer, kidney damage, gastrointestinal disorder and skin problems. The agricultural wastes have the following effects. The water becomes turbid due to suspended impurities and isn't fit for domestic use. It causes respiratory and vascular damage by restricting the amount of oxygen that reaches the brain. It can cause precipitation of proteins in the body, resulting in the damage of the liver. It reacts with the respiratory system and causes acute suffocation by blocking the respiratory tract. Biological oxygen demand (BOD) is the amount of dissolved oxygen needed i.e. demanded by aerobic biological organisms to break down organic material present in a given water sample at certain temperature over a specific time period. BOD can be used to gauge the effectiveness of wastewater treatment plants. Pristine rivers, where there is very little microbial growth, have very less values of BOD 1 mg/L. Untreated sewerage, which is high nutrients, and therefore supports high microorganism growth, has values ranging from 200-600 mg/L. P.S. Dissolved oxygen depletion is most likely to become evident during the initial aquatic microbial population explosion in response to a large amount of organic material. If the microbial population deoxygenates the water, however, that lack of oxygen imposes a limit on population growth of aerobic aquatic microbial organisms, resulting in a longer-term food surplus and oxygen deficit. The marine pollution has the following effects. The nuclear wastes are disposed of in sealed containers in the deep seas. The leakage can cause serious damage to flora and fauna in marine habitat. Oil spills cause frequent death of plankton, fish, coral reef, seafood and marine birds. The oil spreads on water and forms a layer, which is harmful for marine life. Some chemicals in the oil form a black layer on the surface which can coat the feathers of birds and fur of marine mammals. All of them die or drown. When the oil spill reaches the coast, it affects fishing activities and tourism. Freshwater depletion and contamination. Fresh water is naturally occurring water on Earth's surface in ice sheets, ice caps, glaciers, icebergs, bogs, ponds, lakes, rivers and streams, and underground as groundwater in aquifers and underground streams. Fresh water is generally characterized by having low concentrations of dissolved salts and other total dissolved solids. Global fresh water consumption rose sixfold in the last century, at more than twice the rate of population growth. Yet for many of the world's poor, one of the greatest environmental threats to health remains lack of access to safe water and sanitation. Over 1 billion people globally lack access to safe drinking water supplies, while 2.6 billion lack adequate sanitation. Diseases related to unsafe water, sanitation and hygiene result in an estimated 1.7 million deaths every year. Poor access to sufficient quantities of water also can be a key factor in water-related disease, and is closely related to ecosystem conditions. About 1/3 of the world's population lives in countries with moderate to high water stress, and problems of water scarcity are increasing, partly due to ecosystem depletion and contamination. 2 out of every 3 persons on the globe may be living in water-stressed conditions by the year 2025, if present global consumption patterns continue. Water ecosystems both replenish and purify water resources essential to human health and well-being. But the sustainability of many such ecosystems has been impacted by development and land use changes involving elimination of marshes and wetlands, the diversion of surface water or alteration of flows, increased exploitation of underground aquifers, and contamination of water by waste and discharges from industry and transport, as well as from household and human waste. The absolute quantity and the diversity of pollutants reaching freshwater systems have increased since the 1970s. These include not only biological contaminants, for example microorganisms responsible for traditional waterborne diseases, but also heavy metals and synthetic chemicals, including fertilizers and pesticides. Depending on the type of contaminant and degree of exposure, acute or chronic health impacts may result, along with impacts on the environment. Eutrophication. One of the main problems affecting coastal waters is the high levels of nitrogen and phosphorus-based pollutants entering the water. These pollutants come mainly from human activities. Excessive discharge of nutrients into coastal water results in accelerated phytoplankton growth. Eutrophication is defined as enhanced plankton growth due to excess supply of nutrients. Large growths of phytoplankton are known as blooms, and these large blooms can have undesirable effects. Major problems associated with eutrophication are: these blooms occur throughout the water and prevent light reaching the waters below. This stops the growth of plants deeper in the water and reduces biological diversity. When the blooms are really large, this bacterial decomposition can use up so much oxygen in the deep waters that there isn't enough left for fish to breathe and they have to swim away or else they die. Animals living on the seafloor can't easily move away and they also die. Excess nutrients can sometimes encourage the growth of phytoplankton species which produce harmful toxins. These toxins may cause the death of other species including fish in fish farms. Large phytoplankton blooms can cause huge ugly foams on beaches. These blooms are not toxic, but temporarily ruin the beach, reducing its recreational value. Remedial measures. 1. Sewage treatment's adequate care should be taken to ensure that effective sewage treatment process is in place and that contaminated water does not get mixed with the environment. In order to prevent water pollution, human and animal excreta should be prevented from mixing with its sources. Construction of pit toilet and proper sewage treatments can offer some solution to this problem. Sewage contains large amounts of organic matter and microbes, many of which are pathogenic. Treatment of wastewater is done by the heterotrophic microbes naturally present in the sewage. This treatment is carried out in 2 stages. Primary treatment. These treatment steps basically involve physical removal of particles large and small from the sewage through filtration and sedimentation. These are removed in stages. Initially, floating debris is removed by sequential filtration. Then the grit soil and small pebbles are removed by sedimentation. All solids that settle form the primary sludge, and the supernatant forms the effluent. The effluent from the primary settle-in tank is taken for secondary treatment. Secondary treatment, or biological treatment. The primary effluent is passed into large aeration tanks where it is constantly agitated mechanically and air is pumped into it. This allows vigorous growth of useful aerobic microbes into flux masses of bacteria associated with fungal filaments to form mesh-like structures. While growing, these microbes consume the major part of the organic matter in the effluent. This significantly reduces the BOD biochemical oxygen demand of the effluent. BOD refers to the amount of the oxygen that would be consumed if all the organic matter in 1 liter of water were oxidized by bacteria. The sewage water is treated till the BOD is reduced. The BOD test measures the rate of uptake of oxygen by microorganisms in a sample of water and thus, indirectly, BOD is a measure of the organic matter present in the water. Greater the BOD of wastewater, more is its polluting potential. Once the BOD of sewage or wastewater is reduced significantly, the effluent is then passed into a settling tank, where the bacterial flocks are allowed to sediment. This sediment is called activated sludge. A small part of the activated sludge is pumped back into the aeration tank, to serve as the inoculum. The remaining major part of the sludge is pumped into large tanks called anaerobic sludge digesters. Here, other kinds of bacteria, which grow anaerobically, digest the bacteria and the fungi in the sludge. During this digestion, bacteria produce a mixture of gases such as methane, hydrogen sulfide and carbon dioxide. These gases form biogas and can be used as a source of energy as it is inflammable. The effluent from the secondary treatment plant is generally released into natural water bodies like rivers and streams. 2. Prevent river water to get polluted. The flowing water of the river cannot be cleaned easily by natural process. Since a large number of external substances are discharged into the water, the river water becomes polluted. This may cause diseases to the people using river water. Thus, every effort should be made to prevent the river water to get contaminated. People should not be allowed to throw wastes into the river water. 3. Treatment of wastes before discharge. Factories are expected to treat its effluent wastes prior to discharge. Toxic material must be treated chemically and converted into harmless materials. If possible, factories should try to recycle the treated water. 4. Strict adherence to water laws and legislation relating to pollution should be strictly followed by all. People should be made aware that adherence to water laws is in their own interest. 5. Treatment of drainage water in cities. A huge amount of water is put into drains every day. The water that flows through the city drainage system should be properly treated. Harmful pollutants be removed before they are introduced into reservoirs. If this water allowed going into water reservoirs without treatment, it will pollute them. 6. Keep the pond water clean and safe. Washing, bathing of cattle in the pond that is used by humans should not be done. Washing of dirty clothes and bathing of cattle make the pond water dirty and unsuitable for human use. If these ponds are continually misused, then it may lead of severe consequences. 7. Routine cleaning. Ponds, lakes and wells meant for human use should be routinely cleaned and treated so that it remains fit for human use. It is an essential step that should not be avoided. A system of regular testing of pond and lake water can be introduced to ensure the safety of the water. 8. Don't pour insecticides in sinks and toilets. Never pour household insecticides, medicines, etc. down the sink, drain or toilet. At homes, people often throw wastes and old medicines into the bathroom toilet. This practice is discouraged for the reason that the chemical compounds of medicines, insecticides, etc., when mixed with other chemicals, may result in formation of harmful substances. 9. Public awareness. Common public should be aware about the effect of water pollution. Voluntary organizations should go door to door to educate the creating awareness about the environment. They should run environmental education centers. Students can impart health education to enable people to prevent water pollution. Naturally decontaminating water. The cleaning occurs in 2 stages. Firstly, the conventional sedimentation, filtering and chlorine treatments are given. After this stage, lots of dangerous pollutants like dissolved heavy metals still remain. This water is then passed through large marshy area containing appropriate plants, algae, fungi and bacteria which neutralize, absorb and assimilate the pollutants. Hence, as the water flows through the marshes it gets purified naturally. The process of using fungal mycelia to filter toxic waste and microorganisms from water in soil is called mycofiltration. Similarly, use of plants to eliminate toxic waste from the water or other polluted medium is called phytoremediation. Many plants such as mustard plants, alpine pennycress, hemp, and pigweed have proven to be successful at hyper-accumulating contaminants at toxic waste sites. For bioremediation, read ahead. Chlorine, chloramine, chlorine dioxide, ozone and UV rays are commonly used as water disinfectant. Biomagnification, bioaccumulation, and bioconcentration. Biomagnification or bioamplification refers to an increase in the concentration of a substance as you move up the food chain. This often occurs because the pollutant is persistent, meaning that it cannot be, or is very slowly, broken down by natural processes. These persistent pollutants are transferred up the food chain faster than they are broken down or excreted. In contrast, bioaccumulation occurs within an organism, where a concentration of a substance builds up in the tissues as it is absorbed faster than it is removed. Bioaccumulation often occurs in two ways: simultaneously by eating contaminated food, and by absorption directly from water. This second case is specifically referred to as bioconcentration. For example, phytoplankton and other microscopic organisms take up methyl mercury and then retain it in their tissues. Here, mercury bioaccumulation is occurring. Mercury concentrations are higher in the organisms than it is in the surrounding environment. As animals eat these smaller organisms, they receive their prey's mercury burden. Because of this, animals that are higher in the food chain have higher levels of mercury than they would have due to regular exposure. With increasing trophic level, mercury levels are amplified. In the next video we will be discussed about pollution due to solid wastes.